To the class, dear students. In today's lecture, I'm going to do the concept on double integrations with the change of order of integration as well as change of variable of integration. So already in my last previous lectures, we have done with the double integrals with the constant limits and double integrals with the variable limits. These two we have done in the previous lectures. So now how to change the order, what happens if we change the order of integration, and for few of the problems we cannot solve easily by the given order. So what we do is we change the variable also. So there are some few techniques are there to change the order as well as the change of variable. Now first let us do the change of order. The change of order of integration. What do you mean by this? Change of order means, for example, if I write double integral, the function f of x comma y, any function, let us take whatever the function dx, dy is there, and the limits of x are from a to b and y is from c to d. Okay. Now, to change the order of integration. What do you mean by the order of integration here? In this, when we are integrating, the first we are integrating with respect to x and the limits of x are from a to b. Then we are integrating y with respect to y, then y limits are from c to d, correct? Now, if I wanted to see what are the limits of x here, very clear that it is x is equal to a to b. Actually, in the problems, you will not be given what is x and what is y. So, you will not be getting that values, the c to d, that's it. So, in the problems, this will not be given to you. What are x limits and what are y limits? So, you have to find out what are the x limits here. So, x limits are what? A to B. It is what understanding. This is what you have to do is you have to put a bracket here so that you will understand what are the limits of x. Okay. And then what are the limits of y? The y limits are from C to D. C to D. Now, if you want to change, first you want to integrate with respect to y, let us say. Then we write f of x comma y. Now, double integral f of x comma y, first with respect to y and then with respect to x if you want to write. The same integral, this will be equal to this only if you won't change the limits. The limits of y are from c to d, right? Now, you are integrating with respect to y first. So, you have to write y limits as from c to d and then x limits are from a to b. Now, both of them are the same. This will give you the same result. I hope you could understand. I just take an example now. For example, double integral. You have, let us say, some x, dx, dy, and the limits of x is from 0 to 1, let us say, and y limits are from 1 to 2, let us say. Now, what we do? We just integrate. Now, let us do this integration. First, what we do? Integration with respect to x. Now, what it gives us? Integral 1 to 2. Now, integral x is x square over 2 within the limits 0 to 1 dy. And when you solve it, it gives you integral 1 to 2. Upper limit minus lower limit gives you 1 over 2 dy. And therefore, 1 over 2 y within the limits, integral dy is y within the limits 1 to 2. So, 1 over 2 times of 2 minus 1, that value is 1 by 2. So, this is what the integral value of the integral. Now, if you want to change the order of integration, that is what integral, let us now write, the function will be the same, but you want to write x dy dx. Now, what are the limits of y? The limits of y, here we should write the limits, let us say. X limits are from 0 to 1 and y limits are from 1 to 2. We are not supposed to change anything here. Only the order you are changing. So, y limits must be 1 to 2. X limits must be 0 to 1. And then put the bracket and solve the integral. The same thing you have to get. So, now let us see the values here. That is integral 0 to 1. Now here you are integrating with respect to y. So we have to send this x outside of integration. Okay. Because you are not integrating with respect to x. So now let us take x outside. and integral 1 to 2 dy dx, right? Now that gives you integral 0 to 1 x times of integral dy is y within the limits 1 to 2 dx. Now what is this gives you? That is integral 0 to 1 x times of upper limit minus lower limit is dx, and now that is 1 dx, which is nothing but x square by 2 within the limit 0 to 1, and the value is 1 by 2 only. So if you change the order of integration, you are not changing the limits. X limits and y limits will be the same, just you are changing the order. When you write dx dy as dy dx, you are going to change the x limits as x, y limits as y, like this. That's it. This is called as the change of order of integration. I hope you could understand. But now let us slowly enter into change of variable of integration. In this little we have to understand the concepts here. Change of variable of integration. Now in this, let us have a particular, any particular function is there. Let us say I write integral x to some, let us say 1 and 0 to 1, let us say, and there is some function, let us say x only, and then dy dx. Okay, now here there are two things. One is the variable limit, the other is the constant limit. So what we do, we just write down what are the variable limits here. Variable limits, but that means what is the y limit here? Y limit is from x to 1, because you are integrating with respect to y. So y limits are from x to y is equal to x to y is equal to 1, I write. Okay, and the limits of x are from 0 to x is equal to 1. These are the limits. Now here, what are the variable limits and what are the constant limits? These limits are the variable limits. What are these limits? This is called as the variable limit. Okay, that is the variable limits. So the variable limits are y. And what are the constant limits? Let us say let us now write down the constant limits. These are the constant limits. Are x limits are constant limits, y limits are the variable limits. What do you mean by that? Y in terms of x, suppose you have, then that is called as a variable limit. Constant limits are without any variables, you are defining the limits. Now our job is to understand this particular region first of all. So for drawing this, what we do, we draw the lines y is equal to x, y is equal to 1, and x equal to 0, x equal to 1. Now there are few points to understand here. Whenever there is the important points here to understand the graph, important points are, when I say x limits means always you have to see the region from left to right. X limits are from always left to right. And then y limits are always bottom to top. Bottom to top. Why? Because in your x-axis, what is your x-axis? Is always the horizontal axis, right? So you go from left to right for x-axis, and you go from bottom to top for y-axis. So therefore y limits means upper bottom to top, x limits means left to right. This is what one understanding. And one more thing is, what do you mean by x is equal to 0? Means it is y-axis, and y equal to 0 means it is x-axis. So try to understand these concepts and then try to draw the region now. So now we are going to draw the regions. Let us say now, what are those regions? Let us see. First one is, I wanted to draw y is equal to x is 1. The boundaries are like this. Y is equal to x we need, and then y is equal to 1 we need. And what are the other equations? X equal to 0 and x equal to 1. X is equal to 0 and x is equal to 1. These are the things you are going to draw now. So let us now draw the x-axis and the y-axis. Let us say this is x-axis and this is y-axis. As I told you, when I say x-axis, what do you mean by this? Y is equal to 0. When I say y-axis, what do you mean by this? This is x is equal to 0. Okay. Now, so we need y is equal to x. There is a straight line y is equal to x. So it should pass through the origin. Correct? The line should pass through the origin. So this is the line y is equal to, this is the line y is equal to x, right? Now, and now let us now draw other lines now. What are the other lines here? Y is equal to 1 I need, suppose. Y is equal to 1 means what is it? Let us put y is equal to 1 is somewhere here. Y is 1 is this line. And what is the line y is equal to 1 means? Let us draw the line y is equal to 1 is this. Let us write down the equation. This is y is equal to 1. And then we need x equal to 1 straight line also. So x equal to 1 means I can put the line as like this. Okay. This is x is equal to 1. We are drawing all the lines which are available in our problem. Now, what I need to draw y is equal to x from to y is equal to 1. My lower boundary is, bottom boundary is x, upper boundary is 1. So that means what? From my region, I have to draw the figure in such a way that from y is equal to x, that means this is what the line, correct? From y is equal to x, I have to draw for the region y is equal to x is this line, right? This line up to what? Y is equal to 1. Up to y is equal to 1. Like this you have to draw. The line from y is equal to x to y is equal to 1. Like this you can draw or not? Correct, right? Your bottom boundary of y is equal to x to y is equal to 1. Actually, you can draw even this also, because the straight line is up to infinity. It is this whole thing is y is equal to x to y is equal to 1, and even you can continue. Understood? All these are nothing but from y is equal to x to y is equal to 1. I hope you could understand. Now, I wanted the region of x is equal to 0 to x is equal to 1. Now, x equal to 0 means it's your left boundary. Remember, from left to right you have to go. From x equal to 0 means the line it is, correct? The y-axis. From x equal to 0 to x is equal to 1, you are going to draw the line. So that means what? Which is the region now? From x is equal to 0, I draw like this. X is equal to 0 to x is equal to 1. Let me draw like this, okay? X equal to 0 to x is equal to 1. All these region, even the down also. From x equal to 0 to x equal to 1. Even this is the total infinite region. Understood? Now, this is the region from x is equal to 0 to x is equal to 1. Correct? Are you able to understand? And now, I wanted the region which is bounded by all these points, all these lines. So, what it is now? The region which is bounded by all these regions means the common portion, is it not? So, what is the common portion here? Try to understand. The common portion is with green and yellow. What is that? This is what the portion, where you are able to see both. Correct? This is the region. I hope you are able to understand. So now in this region, you are going from x equal to 0 to x equal to 1 means this portion, and you are going from y is equal to x to y is equal to 1 means this is the line. So when I say y limits, go from bottom to top. When I say x limits, go from left to right. I hope you could understand the region now. Now the point is, you are going to change the variable. That means changing the variable means you are going to change y limits as constant limits and x limits as the variable limits. That is what change of variable means. Your y is a variable limit, right? Your x is a constant limit. So interchanging, x goes to the variable limit, y goes to the constant limits. This is what you are going to do now and then solve the problem. Okay. So let us say now y goes to the variable limits. So let us see what is that. Y. So what we are going to change is y limits. So by changing the variable means y limits are constant limits. Constant limits are y. That is, and variable limits are x. Variable limits are x. Because I hope you could understand, they are interchanging their characters. Y is going to constant limits, x is going to variable limits. Understood? Now for the same region, I wanted to say x is a first variable limits. We will check. What is the variable limit? That means you have to write x in terms of y. X in terms of y from left to right. X in terms of y from left to right. That means this portion from left to right, when you are going to right, what is this line? Is the y-axis. That means x equal to 0. And where you are stopping? At the line to the line, x is equal to y. So the limits are here from x is equal to 0 to x is equal to y. This is what the x limits. Now let us go to the constant limit. That means you are not going to put y in terms of x again. You are just giving the constant limits from y equal to which limit to which limit. Actually, you are going to y equal to 0 to what is the upper boundary? The upper boundary is 1. So it is y is equal to 0 to y is equal to 1. So this is what the region you could understand. From y equal to 0 to y equal to 1, first you are drawing, and then let us say y is equal to 0 means, I just put the equation properly. Y is equal to 0, let us say the x-axis. Y is equal to 1. Y is equal to 1 means somewhere like this. So now the region, how can you draw the region? From y is equal to 0 means x-axis to y is equal to 1 somewhere here. So let us draw like this whole region, okay? This whole region, even up to here, all this extended it is, okay? From y equal to 0 to y is equal to 1. This is the region, okay? And now from x equal to 0 to x equal to 5. What is the other region now? From x is equal to 0. X equal to 0 means y-axis. From left to right, what is the straight line? Straight line we draw first. What is the straight line? The straight line is x is equal to y. So let us draw the line x equal to y. Now the straight line x is equal to y. And now what we are going to draw? From x equal to 0. X equal to 0 means y-axis to x equal to y. So what we draw now? Let us draw like this. From x equal to 0. From x equal to 0 to x equal to y. So this is what the region. Even from here up to here, everything. Okay, your straight line also goes beyond this, right? So all these are the x equal to 0. Now, but what we need? We need only the common area. What is the common area in this? This is what the area. So the same area we are drawing, correct? Are you able to understand? This is y is equal to 1. This is y equal to 0. This is y is equal to x. And this is what? X is equal to 1. Understood? This is the limit x is equal to 1. So now this is what the portion from y equal to 0 to y is equal to 1 constant limits, and x equal to 0 to x equal to y. This is what the variable limits. I hope you could understand. So now we are going to find out the solution for this. So let us write down this. The limits are from y equal to 0 to y equal to 1 is the outermost, x equal to 0 to x equal to y is the innermost. So we rewrite the equation, we rewrite the integral now, that is double integral from y equal to 0 to 1, x is equal to 0 to y. Now the function is what actually it is? X. Now x, now it is dx dy. So when you solve this integral x dx, we are integrating this. X dx is x square by 2 within the limits 0 to y and 0 to 1 dy. Now upper limit is y square by 2. Y square by 2 means y cube by 6 within the limits 0 to 1. So the value is 1 by 6. So this is what the value of the integral. I hope you are able to understand how to change the variable. Okay. I'll just do one more problem to make you to understand. Let us take this problem now. Let us have the problem as integral, second one, integral 0 to pi by 2, and let us take integral x to pi by 2, x to pi by 2, sin y by y dy dx. So this is what the limits. This is what the problem. Now what are the limits? One by one write down. What are the variable limits here? The variable limits are y is equal to x to y is equal to pi by 2. What are the constant limits? The constant limits are x is equal to 0 to x is equal to pi by 2. These are the constant limits. Okay. Now what we do, we just put a bracket first. Try to put the bracket and then we will understand. Now let us draw the figure. Okay. Let us draw the figure. What is the figure now? X and y axis. Now what are the equations we have first? Y equal to x, the straight line. Y is equal to x you have. The straight line y is equal to x you have, and the straight line y is equal to pi by 2 you have, and the straight line x is equal to pi by 2 you have. So just like the previous problem, little change, that's it. Now this is pi by 2 and this is y is equal to pi by 2 straight line. This is x is equal to pi by 2 straight line, and this is y is equal to x, and this is x is equal to 0, and this is x is equal to pi by 2, and this is y is equal to 0. These are the names of the equations. Now as I told you, y limits means always go from bottom to top. So how to, now let us shade the region. Y is equal to x to y is equal to pi by 2. Y equal to x is the lower boundary to y is equal to pi by 2. So this is what the boundary up to here, correct, up to here only. Whereas you can go up because the straight line is up to here. This is there is no boundary for infinity. Up to infinity it goes on. Even the straight line y is equal to pi by 2 is like this. So all this goes on to the region which is from y is equal to x to y is equal to pi by 2. I hope you could understand. And now where is the cut here? From x equal to 0 to x equal to pi by 2. Let us now draw the figure draw the region for x is equal to 0. What do you mean by x equal to 0? Is my left boundary, as x limits from left boundary. From x equal to 0 you have to start the region, and to x equal to pi by 2. This is what the straight line. So from x equal to 0 to x equal to pi by 2, what is the region here? This is what the whole region. This is the whole infinite region. But where you have to get the boundary is nothing but the intersection region. What is for the intersection is this is the portion. I hope you could understand. So now this, for this region, you are going from left to right means x equal to 0 to pi by 2, 0 to x, and from bottom to top means y is equal to x to y is equal to pi by 2. Now you are changing by changing of order, change of variable now. Change of variable means what? Y becomes constant, x becomes variable. So x variable, now x is the variable limit now. X variable and y is the constant. Constant will be y. So now, when I want to express x in terms of y, where I have to go from, x is from left to right, correct? So x is from left to right means for this region, I should go from left to right. So my left boundary is x equal to 0, my right boundary is x is equal to y. And I want the constant limits, I should go from y equal to 0 to y is equal to pi by 2. I hope you could understand. So these are what the limits. So now let us normally solve the integral. What is the integral now? Let us take that. So double integral, your x limits are from 0 to y, 0 to y, and y limits are from 0 to pi by 2, and this is sine y by y. Now it should be dx dy. Let us now solve this integral just by put in the bracket like this, and then it is the normal way of integration. Now how do you do like that? So now the foreign element here is sine y by y, correct? So what you have to do, you have to take out this sine y by y because we are integrating with respect to x. So take this outside of the integration. So what you get now, that is given by integral of 0 to pi by 2 sine y by y times of integral 0 to y dx. Close the brackets, dy. Now what it gives you? Integral 0 to pi by 2 sine y by y. Integral dx is x within the limit 0 to y dy. Now what it gives you? Integral 0 to pi by 2 sine y into y by y multiplied by upper limit minus lower limit, that is y minus 0, that is y. Now y gets cancelled. Integral sine y becomes negative cosine y within the limits 0 to pi by 2. Now upper limit minus lower limit gives you the value, minus take out cosine of pi by 2 minus cosine of 0. What is cosine 90 is 0 and cosine 0 is 1. So the value is plus 1. I hope you could understand. Now, okay, let us now do one more problem to understand more clearly. Okay, let us have the problem is these are the simple problems. You just understand how to solve it properly. That's it. Let us now have another problem to make you to understand. Let us take this one now. Integral. Second problem. Double integral 0 to 4, integral 0 to 4, and integral y by 2 to root y, and then 1 plus 2xy dx dy. So this is what the problem. Okay, let us now solve how to do that. Now first of all, what are the variable limits here? Let us write down first all those. What are the variable limits here? Variable limits are y limits, correct? X limits, correct? So that is x is from, what is the left boundary is y by 2. The right boundary is root y. X is equal to root y. Or what you can say about x equal to root y means what? X square is equal to y. Okay. Now, what are the constant limits? Let us write down the constant limits here. Constant limits are y is equal to 0 to y is equal to 4. This is what the constant limits. Right. Now, let us draw the figure. Now, again, we need the axis, x-axis, and then you have y-axis. Y-axis means x is equal to 0. X-axis means y is equal to 0. Now what else we have? We need x equal to y by 2. That means what? Again, it's a straight line passing through the origin, right? So we draw the line which is passing through the origin, which is x is equal to y by 2. The name of this equation is x is equal to y by 2. X is equal to y by 2. And then what you need? We need one more equation, x is equal to root y. So what is x equal to root y means? X square is equal to y. Okay. Right, now let us put in this. Now that is, this is y is equal to y means x is equal to 0. Okay, and this is y is equal to 0, and this straight line is x is equal to y by 2. X is equal to y by 2. And then x equal to root y. Now you need x equal to root y means you should understand that it's a parabola. It's a parabola. Okay, so now it's a parabolic equation. Now if you draw a little more clumsy it is actually, let us draw in this way. Just put like this. Okay, and now let us try to understand what is the equation. This is x is equal to, this is y is equal to 0. This is what the x-axis, and this equation is what? X is equal to root y. X equal to root y is this parabolic equation. And what else you need? Y is equal to 4 is there. Now this also we need. So let us write down what is y is equal to 4 means. It will be somewhere y is equal to 4. It should be somewhere here. This should be y is equal to, because all of them should intersect, otherwise it will not be a region, correct? So let us put it like this. That is y is equal to 4. This is y is equal to 4. This is y is equal to 4. Now we got all the equations. All the 4 lines or all the 4 curves we have got it now. Now let us shade the region. What is the shading now? Let us see. Where you have to go from x is y by 2 to x equal to root y. What is x is y by 2 from left side? From left, your left boundary is x is y by 2. To the right boundary is x equal to root y. So where you have to go? This is the portion. The portion is this one. This is the portion, correct? From left to right. You understand that one? That is from left boundary is this x equal to y by 2. Right boundary is x equal to root y. And now y equal to 0 to y is equal to 4. So y is equal to 0 to y is equal to 4 means let us draw that boundary also. There. Now actually this is what only the boundary. Now when you draw the figure with y is equal to 0 to y equal to 4. Y equal to 0 means x-axis. Y equal to 0 means up to from to y equal to 4. All this actually. All this. Let me draw like this actually. You will understand more easily. Y equal to 0 to y is equal to 4. Y equal to 0. Y equal to 0 means x-axis. To y is equal to 4. All this region. All this region is y is equal to 0 to y is equal to 4. Even that. Y equal to 0 to y equal to 4. Now what is the common region? The common region is this. Correct? The common region is given by this portion only. Actually this portion. You can write y x is equal to y by 2 is this. X equal to y by from 0 to, right? X equal to y by 2 to x equal to root y. So from here to here. So this is what the region. Common region is this, correct? The common portion is that. So now this is what the region you understood. Now we are going to draw the we are going to change the variable. What is the variable now? We are going to change it into, we are going to change the variable limits as y limits. So now the variable limits are y limits. Y limits are from, and the constant limits are x limits. Constant limits are x limits. So y limits are the variable limits, means from bottom to top. You have to write from y in terms of x. So what is from, when you go from bottom to top, that means in this region when you go from bottom to top, this is what the portion, right? So you are going from parabola to the straight line. What is the parabola? Y is equal to x square is the parabola. To what is the straight line? Y is equal to, when I write x equal to y by 2, I wanted to write y. So what is y? It is equal to 2x. So to the straight line 2x. And then when I write the constant limits, means the number you should write. Constant limit, when I go from left to right, what is the value of x? Is 0. And what is the region here? Up to here you are going to write, right? So what is the point of intersection of this now? When x is, what is this point actually? This is y is equal to 4, correct? When y is equal to 4, what is x? It is 4 by 2, that is 2. So we are going from x is equal to 0 to 2. So to understand this, you have to find out the limits here. What is the value of x when y is equal to 4? This limit is what? Y is equal to 4, correct? This line is y is equal to 4, right? This point of intersection is that. So you have to find out that one. So with the help of this limits, now you are going to write down the double integral. Now the function is what? 1 plus 2xy. 1 plus 2xy. Now first is y. So and then next is x. And y is going from x square to 2x and x is from 0 to 2. Now do the integration with respect to y. What it gives us? That is integral of 0 to 2. Integral dy is y. And now what is the foreigner here? The foreigner with respect to y you are doing. The foreigner is 2x. So take it out. So now that is 2x times of integral y becomes y square by 2. Now y limits are from x square to 2x. Here also y limits are from x square to 2x. And then do the integration with respect to x. Now let us see what it is. Integral 0 to 2. Upper limit is 2x. Lower limit is x square. Plus. Now this 2 gets cancelled. You can write x times of upper limit is 2x the whole square minus lower limit is x square the whole square dx. Now what it gives us? Integral 0 to 2, 2x minus x square plus 2x the whole square is 4x square, correct? It is 4x square. 4x square into x becomes 4x cube. And this is x power 4. X power 4 into 4x is x power 5 dx. Now solve this. 2x means 2x square by 2. X square means x cube by 3. 4x cube means x power 4 by 4. X power 5 means x power 6 by 6. 2 gets cancelled. 4 gets cancelled. Put the limits from 0 to 2. So let us solve this. Upper limit is 2 square minus 2 cube over 3 plus 2 power 4 minus 2 power 6 by 6. And the lower limit is 0. So when you solve this, you will be getting this as what? 2 square is 4 and 2 cube is 8 by 3. 2 power 4 is 16 and then this is 64 over 6. So when you solve this, you will get this value as 6.66. This is the solution. I hope you could understand how to solve the problem of integration. You have to see the limits properly and understand, and what to write for y is important when you are changing into y. and then start the integration. That's it. I hope you could understand well. Thank you.